Hello students, good morning to all of you. Students, in today's class we will learn dynamics of circular motion in unit 3rd, laws of motion. Okay. Before we learn dynamics of uniform circular motion, first I will recall you what is a uniform circular motion. As you know, a body is said to be in uniform motion if its speed is constant throughout the motion. Clear? Now, second part is circular motion or uniform circular motion. A body executing a uniform circular motion if its speed is constant in the circular path. Clear? Now, how it is possible that a body is moving in the circular path? Just we understood. Suppose this is a circular path of radius r with center O, and when we draw the tangent on this circle, then we get the direction of its linear velocity at every point by drawing the tangent on the circle. Clear? Now, this is the direction of the linear velocity, and because the body is moving in the circular path, then it is observed that at every time a force is acted along the center which try to move the body in the circular path, which is always acted perpendicular to the tangent of the circular path. Okay, this, and here also this. So we will observe that the body is moving always in the circular path along with this force or due to this force, because this force is always acted towards center and along the radius of the circular path, or we say the along the perpendicular to the tangent and along the center of the circular path. So because this force is acted towards center, so this force is known as centripetal force. Okay, so we can define this centripetal force as centripetal force is the force required to move centripetal force is the force required to move an object in the circular path. The circular path. This force always acts along the radius and towards the center of circular path. Clear? So A centripetal force is the force required to move an object in the circular path or say circle. This force always acted towards the radius along the center of the circular path. Okay. As we learned earlier that if a particle initially at point P and after some time it reaches point B, it will observe that it will swept an angle by this arc PB at the center. This angle is equal to omega t, and this v is the linear velocity at point P and the object is moving towards AB. Then in the circular motion we will understood about the linear velocity is linked with the angular velocity by relation v is equal to omega r, and in circular motion we will calculate that. So we know that when a body moves in circular path, or we say along the circle, okay, then its motion, its acceleration is called centripetal acceleration, centripetal acceleration, and it is given by A is equal to v square upon r, and because we have v is equal to omega r, therefore this acceleration is become omega square r square upon r, which is we get A is equal to omega, or we say r omega square. This square cancel by r, or we get the result is r omega square. This we have the value of acceleration when a body is moving in the circular path. So the force experienced by the particle moving in the circular path is, we know that F is given by the product of mass into acceleration, and we have the value of acceleration in the form of linear velocity. So we get the centripetal acceleration, or the centripetal force, is equal to mv square upon r. This is one or first relation in the form of the linear velocity, and because the particle is moving in the circular path, so it have the angular velocity, therefore the force acted on the particle is in the form of angular velocity is mr omega square, as we have the centripetal acceleration A is equal to v square upon r, and second value is A is equal to r omega square. So this force is required in the circular motion, or when an object is moving in the circular motion. Okay, note down this. So it is very clear, student, from the figure also. The when a body is moving in the circular motion, then direction of the velocity is changes at every instant of movement. Clear? So we say when a particle is moving in the circular path, its velocity or direction of velocity changes. So it is clear that when an object moving along circular path then its speed is constant, but velocity changes at every point. Okay. Now next, when a body is moving in the circular path, then as the body have a tendency to move in a straight line path, so a force is acted in the reaction of the centripetal force, which is just acting in opposite direction and along with the radius to the centripetal force, is known as centrifugal force. So centripetal force is acted towards center and the centrifugal force is acted outward from the center, and it is sometimes assumed as by the student centripetal force, but because the centripetal force is worked outward, is not is not centripetal, it is known as centrifugal force. Okay, now we understood what is a centrifugal force and what are the application which is related to centrifugal force. Centrifugal force. Okay, this force or centrifugal force is arises when a body is moving actually along a circular path by virtue of virtue of its tendency by virtue of its tendency of the body of the body to regain its to regain its natural straight line path, natural straight line path is called centrifugal force. This force is retarded this force can be retarded as reaction of centripetal force. Centripetal force. Therefore, value of centrifugal force, value of centripetal force is equal to value of centrifugal force. Centrifugal force, that is centrifugal force F is equal to mv square upon r as a reaction of centripetal force. Centripetal force. Clear? Therefore, because it is the reaction force of the centripetal force, hence the direction of centrifugal force is in opposite direction of centripetal force. Centripetal force. Therefore, centrifugal force acts along the radius of circular path circular path and away from its center, away from center of circular path, where this is centrifugal force. And the examples where the centrifugal force is work is when a car is moving in the death wheel, then the force acting on the car is centrifugal force, not centripetal force. ठीक है, इसी तरह से the force on which the washing machine is based is also centrifugal force. Similarly, जो हमारे घर में जो जूसर मिक्सर ग्राइंडर यूज करते हैं, it is also based on the same principle or fact on the centrifugal force. Okay, so note down this. So student, in the next class we learn about the rounding of curved rod, and then after we discussed on the principle of banking of a level rod from one end. ठीक है, and then we derive the relation for the motion of a cyclist on the curved road. Thank you.